Hi there, welcome back. The saga continues. I'm following my logic of coming back from the power amplifier, and if you look at the schematic, the power amplifier over here is fed through that cable, or that connector, with left channel, right channel and ground from this board over here. And this board over here is that little board we have at the top there, with its copper side up, which has the mono switch, the stereo switch, rumble filter, noise filter, and the tuning bypass. Now, my logic was, if I'm getting the signal from here, I've got to get it going from here through. Okay? Makes sense. However, what I found was, when I fed the signal in here, I got absolutely nothing on that end. Nothing at all. And what I was finding was that I wasn't getting these voltages here. This is supposed to be about 8.5 volts across that resistor, and there was zero. So I checked and there was no supply voltage. And this is where I followed this through this connector here to see where the hell it went. And it went to various boards, but ultimately it went back to that board that I removed, which was the first point that received 25 volts. Now, that means that 25 volts went into that board and then came back out of that board on another pin of that socket, of that connector, and then fed the other boards. So all this time, that 25 volts has been feeding absolutely nothing. So I had to bypass the two pins. I had to put a connector, a crocodile clip, and I connected between the two pins so that I could get 25 volts coming to this board. And we now have it. We have 25 volts coming to this board over here. And it's coming through various boards, by the way. It's not just one board. It comes through various boards and finally gets to here. And you can see that if you follow all this across the entire schematic. But ultimately, I feed a signal in here. I will feed a signal in here and show you what the result is on the speakers. Now, the point where it's connected is actually over here. This is the rumble filter switch. It's to 1 and 4, so that one and that one. So I'm going to connect to that one first, and I'll connect to that one second. Again, I'm monitoring the two speaker outputs. I'm going to connect it to the left side. Perfect. 1.74 volts. You can see that. Connected to the left. 1.76 volts. And it's not synced because I've got the scope triggering on channel A. But there you have it. Okay, I want to show you the effect of these filters now, or some effect. We know the rumble filter is supposed to be for low frequencies, so if I activate it now, you get a slight drop. This is 600 Hertz. If I come down to 200 Hertz, slightly bigger drop, 100 Hertz, bigger drop. Let's go to 50 Hertz. See? A hell of a drop on 50 Hertz. Okay? Now, if we try the noise filter here, very small change, but if I take this to, say, let's try it on 1 kilohertz, noise filter on, very slight change. Okay? Let's try 10 kilohertz. There's already a drop anyway, but if I hit the noise filter, look at that. It cuts it way down. So if you want to hear hi-fi music, don't use the noise filter. It's a very big effect. But we know this section of the circuit's working. So now we've got to see where it comes from. And where it comes from is actually from the preamp board. This board over here. I'm not going to mark that one as green just yet because the actual board has more things on it. There are a few switches that come onto the board having to do with the tuning meter and also with the mono and stereo switch, which we haven't tested. That's on that board. So we'll leave that blue. That's supposed to be blue, not green. Now let's get to the preamp board, which is this one over here. And now what do we have? We have the preamp board is feeding out the signal to the that filter board up there, which we've tested. Now we've got to see if the actual signal is getting through here. But we have supply lines here as well, which I need to check. I'm going to check whether that supply is there. I'm going to check whether these connections come in, whether the supply is coming in there, and then we'll feed the signal over here. There's ground, and there. So that's the next thing, but I'm not sure that I'm going to do this before recapping. There are quite a few caps on there. I'll think about it. Okay, so we've checked this board over here. This is the rubble filter and the noise filter. That seems to be working okay. There are no caps on here. I then found the signal goes through to the preamp board. This underneath here is the preamp board. This is quite easy to remove. You just undo two clips on here. They come out. This white sheet comes out. The dial lamps just twist out as well. And you're then able to remove the board. And that's exactly what I did. There was a screw missing down here, so that's been replaced. The caps have been replaced. There are 2, 4, 6 caps on here. They've been replaced. 4 of them are actually directly in the signal path. So I've used some very good quality Nishikon caps for that. The supply filtering I've used, they're not cheap caps, but they're normal caps. So this, in our condition at the moment of lack of spares, I've had to make a little bit of a compromise there. But anyway, the signal coming from the filter board goes to there. In fact, it's the other way around. I beg your pardon. The signal goes from the preamp to the filter board, and from the filter board, it then goes to the power amp. So I'm working backwards. Power amp, filter board, preamp. Now this thing's completely done, and I want to check it. And again, I've got to be careful here because I can't really remove some of these sockets to check it, which would be ideal, because in this case, these connectors actually carry the B+, the 25 volts around here, and the 15 as well. So far, with the preamp board, we haven't come across the 15 volts yet. We just need to make sure that the 25 is getting here, and it is, with that little patch that I did on that connector, on the IF board that I removed. So I'm now happy with this section, and I want to do a test. And I found the best place to test it is actually on that board over there. I've followed the input lines from here, and I found that it's that guy there, this one here, and this one here. So I'm going to connect the signal to those two, and it's going to go through the preamp board, and then we can test all the controls. That should be quite good. Let's set that up. Everything connected. I've got the signal coming in, and I've divided it through the two caps again to feed it into those points on that board that I showed you. So effectively we've got the entire preamp section on display here, and we'll see what happens. I'm going to switch the signal in. I've got a 1 kilohertz sine wave coming in, 20 millivolts, very low, and we'll look at the scope, and then we'll play with these guys over here. Volume. Now remember, that thing is measuring at the speakers. Got maximum volume on here. There's a discrepancy between the two. This is where this second control, what is it, Pegel? This is sort of a level control for the two individual channels. I'm moving the back one to max. There it is on max. Front one to max, and that's what we get. Now we can do that. I may be wrong and somebody can definitely correct me, but this is sort of a better balance control than what you'd normally get, because when you normally do balance control, you can never quite get rid of the one signal. Look at that. If I put, this is almost an individual volume control for each channel after it goes through the main volume control, which I'm wiggling here. So you've got a main volume control, which is a dual pot, and then you set your levels for each individual channel. If you start on max, they're equal, and if you decide that one side needs to be brought down a little bit, you can do that, or the other side. So that makes sense. You literally cut out all the signal from the second channel because they're literally volume controlled independently. So that's the way I understand this thing to work. But I'll put that on max. And as we can see, we've got the whole thing there. 2 sine waves, very equal, very low level. I've got 20 millivolts coming in here. I'm going to put 100. And obviously adjust there. There we go. That is 11.9 volts. 11.8, 11.9. Those are very, very close. Now I'm going to drop the volume a bit because I'm not sure just how good my... you see there's a little bit of non-linearity when you go down here. You can see a slight difference in the two. At lower levels. It's definitely obvious. There's a section of the volume control here that is not linear. It's linear over here. Let me drop this to 80 millivolts RMS and we can show you better. And then it gets to this point and it's not linear. And then you go higher. Let's try 50. You go higher and it sort of starts correcting itself again. So there's a section of the pot that where you have a slight difference between the two. Remember, this is a dual gang pot. There's a slight difference between the two in terms of linearity. But then, of course, when you get to the top end, they're equal. And this is where you can adjust this guy, the regel. If you wanted to do that, you can actually adjust it. I don't have the knob on, but you can adjust it and get exactly the same on the two. So there we are. We're seeing 1.6 volts again on there. I don't want to stress the dummy load too much. Okay, what I try to do here is to get this exactly down to 2 volts. Practically there, both sides, 2 volts. Because now I want to test the other controls. This is the highs. That's on max. I'll bring it down to minimum. Hang on, that's tiefen, that's bass. So you don't see much difference on here. Put that on maximum. Treble, you'd see a little bit of change on here. Not much either. But if I go to higher frequencies, let's say 5 kilohertz, then if I play with the treble, yeah, you can definitely see the difference there. And if I go down to 200 hertz, 200 hertz, let's see what happens to the bass. There's the bass cut. Okay, and I've actually cleaned out all the pots. Every time I take those connectors out, I spray some contact cleaner in them just to make sure we get good contact. So it looks like that section's done. Let me show you on the schematic where we are. Alright, well that's not looking too shoddy, is it? We've got ourselves quite a few boards done, all painted green, light green. There's the filter board, and here's the preamp. That's the one we're going to look at a bit more, show you what I've done. And here we are. So, we have various connectors here, and these two connectors at the top here are interesting. these connectors had me a bit baffled. These ones here we've seen. That's the output to the filter board. 1, 2, 3, left, right, and ground. Down here, 1, 2, 3 connectors. These go to the mono and stereo switch on the filter board, which has been checked. That's been checked. We have these guys over here, which are the inputs, and that's where I connected to the solder point on the previous board, which is the one over here. 1, 2, 3, no problem. And here we have the connector for the 24 volts. That orange line is the 24 volts, and that's the only supply, including ground of course, that we have on this board. All right. This one had me baffled, so I had to follow it. It's quite a journey. Follow it. It comes down here, goes across here, and it goes to the on-off switch. It goes to the same switch as your mains on-off. Well, it's sort of separated. This is our switch diagram, and we're looking at that guy over there. Netzschalter, switch, on-off switch. Okay, now what does it give us? It gives us two sets of connectors. These at the back here, and these here are obviously the power switch. It actually switches off and on both lines, and mains and neutral, live and neutral. And then here we've got this switch, which is 1, 2, 3, 4, 5, 6, and 1, 2 is normally closed. So when you activate it, 1, 2 flips from there to 2, 3, and 4, 5 moves to 5, 4. So if we remember that and we go back to the schematic, we'll see what this thing does. I'm going to take that off just so that we can see 1, 2 is normally closed. In other words, this is in the off condition. And that means that the connection between that incoming line and ground is made, it's shorted to ground when this switch is not active. In other words, when this switch is off. In other words, when there's no power to your system. Because when you activate the switch, it provides power. Okay? So I figured, well, what the hell was that? And then I remembered the previous one I've done, the GRUNDIG 3160 had a similar situation. It had a shorting of something when you switched off the radio. The idea is that as you switch it off, the instant you switch power off, that connection is made. And I remembered from the previous one, it's exactly what the GRUNDIG was doing. So let's go back and see what it does. So here it is over here. And when it comes down, if you see that line coming down, that one, which is going to be shorted to ground, that's ground over there. See that? That's going to short to there when you switch off. And what is that? Well, that is the output from the preamp to the filter board. In other words, the minute you switch power off, this point here is shorted to ground, meaning you get zero signal over here, meaning that no audio goes through the audio board, so you don't get this sort of fizzle effect when you switch off power, because the caps still have charge. And if you left this on here, you'd keep hearing sound after you switch off. So this is effectively an instant mute when you switch off the power. Again, a nice little trick there. I don't really like the fact that you've got this line going all the way to the mains connector. This is shielded cable, fair enough, but it still sort of picks up something. But anyway, that's the way it was designed. Clever idea, very clever idea. But what do we have here? Well, we've got, this is ground, we've got us looking at the one channel, we've got signal coming in. It goes here to the top of the volume pot. The volume pot again has got those taps. A here is ground, E is the top of the pot, and S is your wiper. So that would effectively be a normal volume control. But it has these, 1, 2, 3 taps. And these taps, as I've described before in the GRUNDIG, are effectively tone shaping depending on what level the pot is set at. So you get a sort of psychological volume control as you go down in volume, and therefore doesn't cut off your high frequencies so much, or it filters, it actually tapers some of the frequency range that gets through to here, depending on where this wiper is on the volume control. Okay. Again, I tried to describe this fairly in fair detail with the Grundig, the previous project. So the signal then goes into here, and here we have, again, we have this pot. It comes down here. Where does that go? It comes out here. It comes out here, and this is where you've got your stereo and mono switch. Okay, that's what that's all about. And if we carry on through here, you then adjust the level of this side. Remember, this is one preamp and the bottom one is the other channel. So you switch between mono or stereo with on the end of this line going down, and then you've got another volume pot which is also 25k. This is 25k VU, which is, I think, linear. This one is log. And your signal level then comes through this coupling capacitor. That's one of the ones I changed. I used a Nishikon. It goes into this transistor amplifier. That one there is also changed. It's just basically filtering the supply, part of the supply. This transistor amplifies, it goes through there, and that is the output. Sorry, that's the output over there. So this is basically just an amplification stage. I would imagine with quite a bit of gain. Yeah, I haven't done the calculations, but I would imagine it's got quite a bit of gain over here. And then it goes through a 10 microfarad coupling cap to this here, which is the tone control circuit. And this, if I'm not mistaken, is it Boschendal? I think that's what it's called. I'm trying to remember this from some of the guitar circuits I played with and designed. You get treble and bass. The advantage of this is that this particular configuration of filter has a very good, it tends to leave the middle exactly the same. In other words, it tends to be a cut, boost, boost, cut. So you end up with the treble boost doesn't really affect the bass section, and the bass effect doesn't really affect the treble section. If I remember correctly, this is one of the neatest, more separate types of filters you can get. I may be wrong. Again, correct me if I am. Your signal comes out of here, and then it's boosted again just by this simple transistor amplifier. It's using a 550C. That's a very quiet transistor. And then it goes out here through a film cap. This is your audio out. And that's the one that gets shorted to ground through that top switch to silence the thing. And that's basically it. Our preamp is done. And it's actually working very well. There was not really much wrong with it, quite honestly. I checked some of the resistor values. They seem to be fine. So I was quite happy to take this board and paint it green. But then, of course, you've seen this, right? This is the next step. Because I want to be able to switch or feed a signal into the tape input. And I want to follow that signal, make sure it's doing what it should be doing, and then be able to just feed the signal through this whole circuit that I've just done and all the stages we've done, and just feed it into the audio input circuit. And the cleanest or easiest one is the tape input. However, it does go through a little bit of a boost circuit. And if you see how it works here, this is the input, that's the output. In other words, when you put a tape deck on here, you would be able to play it or record on it. We are playing on it, okay? So center is ground. This is labeled 1, 2, 3, 4, 5. Don't ask me why, that's the way it is. And these 2, 3, and 5 are the inputs. And this is how it works. The signal, left channel, for example, goes up here, 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 here. That's your tape switch, switch 502. I've written tape in there because I've checked. This one here goes in here, up, 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 and it's going to do the same to the tape switch, the other section of the tape switch for the other channel. So we won't look at that for now. Now what happens on this switch? Well, this switch has this switch has a short to ground, as you can see. So when your tape is not selected, this is the condition it's in. It's shorted to ground. In other words, no signal is going up here to get through to this preamp board. All right. Let me just make sure that I've got that logic right. Yep, I think I do. So it basically quietens any audio that's coming into the tape socket. But when your tape is activated, your signal goes up here, up there. It's not going to go back because your phono, which is deactivated automatically when you activate tape, is in that position. So your phono is silenced. And the signal has to go along here. And then it comes down. And here you've got your monitor switch. Now your monitor switch is from this guy over here. And I haven't followed that logic yet, but when your monitor switch is off, that's what you're getting, right? It's not activated, so the signal goes straight through here, in here, and it comes into this thing. And this thing is one of these, it's the smaller vertical board. It's the daughter board that's sitting vertically on the main board underneath. And all it is a voltage, it's a booster, it's a signal booster. You've got a 1.1 microfarad coupling cap here, and you've got a normal booster amplifier over here. Very similar to the one we saw on the tone control circuits, all right? And there's one coupling cap here, 4.7 microfarad. Again, that was replaced with a good quality one. And boom, it comes out onto your preamp. That's your audio out into the preamp. Now, there's a slight problem, not with this, okay, not with this at all, but with the switch. Now somebody has actually gone to this switch and he has removed this ground connector. He's actually deactivated this section of the switch. In other words, when your tape is not selected, it is no longer shorted to ground. And I don't know why. I can't figure out why they do that. They actually damaged the board. They ripped out the solder tag that makes this ground connection, and they passed a wire over it because it carried on the other side. The connector in the middle is the actual switch point. That tag has been ripped out, removed, and because the ground connection was required on the other side of the switch point of what would have been a solder tag, they've actually passed this stupid little black wire over it just to make the circuit. And that's what I can't understand. So, yeah, we'll have to do a bit of thinking about that because I'm loath to short it out. Nothing's going to happen if I short it out. But I want to, before I do that, I want to understand why they did this. Because it is an interesting, it's a hack. It's not even a mod. I just can't understand it. And I guess the only thing I could figure is if they plugged something in here that didn't like to be shorted to ground. Let's say something that would have seen a short on the output as a fault condition. It could be that, you know, you might have something that doesn't like being shorted, the output being shorted, and I would imagine quite a few pieces of equipment wouldn't like its output to be shorted because it probably would not be able to drive zero input impedance. Yeah, that makes sense. I'm thinking it out loud now. When you have this thing going into here, you know, it's doing its normal business. It's going through here. It goes into here and it sees a coupling cap. And then the impedance, the input impedance over here is, well, what would it be? It would be 1.5 meg in parallel with 1 meg. So it would be like, you know, 700 kilo ohms. It's pretty high input impedance, all right? What happens if you don't select tape, but you've got the same piece of equipment feeding this line? Well, then you've got a zero input impedance. This thing, whatever you're feeding, would see a shorted output, which is the same as seeing a zero input impedance into your piece of equipment. Now, that might not be a good idea at all. So it might in fact be a good idea to leave it. I'll have to think about it. I'm not going to make a decision right now. It might damage whatever you're feeding here. Now, most pieces of equipment like CD players, MP3 players, I'm not sure how they react when you short the output for long periods of time. Remember, this is now, you've got a CD player connected on here and you leave it for a week while you listen to radio, all right? And then suddenly you click it on. I don't know how that piece of equipment is going to enjoy being shorted to ground all that time. It might damage it, and this is probably why they did this. And this thought hadn't occurred to me. I was just thinking out loud. So I might actually consider leaving it there, but I'll neaten it up. I don't like the way it looks. Well, I think for now, that's where I'm going to stop. I've got quite a bit more to do. I want to now do all the switching, and then we'll be ready to move back in the set, and we're nearly getting to the dreaded IF board. And we've got a few headaches awaiting us, I'm sure. I just have that feeling. The hack has been in here, so we'll see. Anyway, I hope you've enjoyed this little episode, and if you did, please click like, share, subscribe, and all that jazz. And if you want to be notified of new videos when you subscribe, push that bell icon. It does help. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now, and stay safe.